Hey guys, long time no see. Hope everything's going well. As you can see, I'm wearing my baseball getup because it's baseball season. And I'm totally jonesing to get my team out on the field, but obviously that's not going to happen. Hold on, I'm going to zoom this in just a little bit so you guys can see it a little bit better. See what I'm doing. There we go. Hey, nice close-up of my nose, huh? That was awesome, right? So guys, today I just wanted to go through in my own language, just like we've been talking about in the past, how to solve systems of equations using substitution. Okay? The key thing to always remember with this is you use substitution in a very specific situation, and it's always a situation when you have one equation in standard form, like this 2x plus y is in standard form. Remember, if there's an x and y on the same side, it's probably standard form. And then when you have another equation in slope-intercept, which is a y equals mx plus b or y equals x plus something. Okay? So standard form, slope-intercept form, that's the best time to use substitution. If it's not in those two formats, it's probably better to use a different solving method, which we'll talk about more next week. But in this case, we have one in standard form and one in slope-intercept form. So all I'm going to do, since I know a system of equation is just two lines on the same graph, and there's a point at which they cross, and that's my solution, I know that these y values, since there's a system of equation, are going to be the same anyways. So all I'm going to do is take my pen and not drop it. I'm going to take this equation and I'm going to plug it in to that y value. So I'm going to rewrite this now as 2x plus. I always bring in a parentheses and throw in what I'm substituting. And the reason I do that is it makes it really hard for me not to mess up with my signs. Okay? Now if you remember from class, I said this gets super redundant after a while because it's always, once you get to this point, it's always distribute, combine, isolate, solve. Distribute, combine, isolate, solve. Distribute, combine, isolate, solve. I could probably write a song for you guys on that one, but the way I started that one, that was kind of ridiculous, so we're not going to go that route. But with that being said, let's distribute. Now this plus sign here, there's nothing after it, but that's just like a plus 1. So I'm going to just distribute this in, and what it does is it goes 2x, and that becomes a plus x, because a plus 1 times x is x, plus 1 times 5 is plus 5. Okay, so it didn't change anything in this case, but if that was a minus, that'd be a different story. But here we go. We're down to here. We have 2x plus 5 equals negative 4. So I just distributed. So now I'm going to combine like terms. Those are like terms. So now I have 3x plus 5 equals negative 4. Okay? Then, now that I've distributed, now that I've combined, so here we'll even write it here. Distribute, combine. My next thing I'm going to do is isolate. Okay? So when I isolate this, I need to get my x by itself, so I have to move that 5. To move this 5 to the other side, I take its opposite. Minus 5, minus 5. And the reason that works again, there's your Miss Erickson line. 5 minus 5 is 0, so that's away on that side. Negative 4 minus 5 is negative 9, and I'm left here, 3x equals negative 9. Okay? So now I've isolated. I'm not quite there yet because there's still that 3. So to get rid of that 3, I just divide by 3, and I'm left with x equals negative 3. Because a negative divided by a positive is a negative, so x equals negative 3. Okay, now I'm not quite done yet. I know that my x equals negative 3. However, I still need to solve for what my y equals. So to do that, I'm going to take this negative 3 now and substitute it back into my original equation, which was y equals x plus 5. So right here, I'm just going to go y equals, parentheses, negative 3, because that's what I'm substituting, plus 5. Y equals negative 3 plus 5. Y equals 2. And that is my solution set. If I wanted to write it like a pro, like a grapher, I would just write it as parentheses, negative 3, my x value, my y value is 2. But this is more than good enough for what I'm looking for. Okay? So that's how we solve those. Okay? The first thing we do is we identify our slope-intercept form. We plug it into our standard form. Then we distribute, we combine, we isolate, and then we solve. It's that simple, guys. Okay, let's look at another one. I got all day. I'm actually heading up to the building in a little bit because I'm going to steal a whiteboard so I can start doing this on whiteboard because my expo markers don't work well. So here we have this equation. We have 2x plus y equals -9, and we have y equals 2x minus 1. Okay, that's the systems of equations. It's two lines on the same graph. Okay, so I'm going to identify which one's in slope-intercept and which one's in standard form. Here is my slope-intercept because that's my y equals. Standard's always an x plus y on the same side and equals something else. So this is my slope-intercept. This one's my standard. So I'm going to take my slope-intercept form and I'm going to plug it in to that y value, since I know both y's are going to be the same because this is a system. Okay, so I'm going to go 2x plus parentheses 2x minus 1 parentheses equals -9. That's really good looking math right there. Good parentheses. It's fluid. You guys can actually read my handwriting. It's good. Okay, so from there I'm in my distribute. So I'm going to take that plus sign in, which leaves me with 2x plus 2x minus 1 equals -9. Okay, I'm going to combine. There's my like terms. 4x minus 1 equals -9. I'm going to isolate. Okay, move that 1 to the other side. That cancels there. Okay, I'm going to divide to leave it all by itself, and I get x equals -2. But I'm not done yet. I still need to plug it into my original equation. So if I have y equals 2x minus 1, okay, I'm going to plug my x value back into that. There's my parentheses. 2 times -2 is -4. So y would equal -5. And in coordinate form, it looked like that. Okay. Now, those were both pretty simple ones because there wasn't too much going on with the y up there. So let's just look at one more one that's just a little bit more complex, and we'll get after it. Piece that out over there. Okay, so here we have y equals 6x plus 20. Bigger numbers. You guys usually don't like those, but it doesn't mean it's a harder problem. Okay, and we have -3x minus 3y equals -18. Now in that systems of equation, this is my slope-intercept form equation. This one is my standard form equation. So I'm going to take my slope-intercept form and plug it into my standard form. So now I have -3x minus 3 parentheses 6x plus 20 equals -18. Okay? And then I'm just going to do what I've been doing. I'm going to distribute, I'm going to combine, I'm going to isolate, and then I'm going to solve. So when I distribute this -3 in, I'm left with -3 times 6 is -18x, -3 times 20 is -60, and that all equals -18. Okay? Now from here, I'm going to combine. There are my like terms, -3 and -18x. When I combine those together, I get -21x minus 60 equals -18. Okay? Now when I isolate, I have to move my 60. That comes out here, and I'm left with -21x equals 42. Okay? Now I'm not quite done yet because I still have that -21 to deal with, so I'm going to divide both sides by it. And I get x equals -2. So there's my x equals -2. And the next thing I need to do is just plug it back into my equation. Now it doesn't matter what equation I plug it into. It's always easier if you choose the slope-intercept one. So let's take that y equals 6x plus 20 and plug my -2 in for the x. -12 plus 20, so y then is equal to 8, and in coordinate form it looks like this. Okay, cool. So that's how you solve those. Just quickly walk through. I know it actually wasn't that quick. It was probably like an 8 to 15 minute video, But there's some good ways, at least hearing it again. Like I said, this is a review. We spent a good 3 weeks on this, and piecework getting up to this point. So again, this is review, but that's how it's done. You take your slope-intercept equation, plug it into your standard form equation for the y variable. Then you distribute, you combine, you isolate, and you solve. And that's how it gets done. So check back in tomorrow. I am going to do a test review tomorrow, which I'll walk through 10 questions that will be very similar to the questions that you'll see on your test on Friday. And you'll have the weekend to take the test. Again, your first 3 attempts, I'll take the highest score. Every attempt you do after 3, I take the averages of all your scores. Okay? So if you take it 20 times, I take all 20 scores and add them together and divide it by 20, and that'll be your final score. Okay, so just know that's how it works. Once you ace it, I stop your counting. So for those of you that were thinking like, hey, I could bomb it a bunch of times, but then just go through and do the 100% of it a bunch of times and get my average up that way. Doesn't work that way, unfortunately, but I'm not thinking that's going to happen anyways. Good luck on your work today. It should be a pretty light day. I'm just going to have you guys work through a few of these to make sure you're getting it. I'm trying to respect that 20-minute barrier, and I know this video is taking up way too much time. So there you go. Take it easy. See you guys tomorrow.